Right, so welcome to this video. We are going to be revising our quiz one. That's medical mathematics for UNILAS. Okay, so there are about 20 questions here, and they're on trigonometry and differentiation. We're going to answer all of them. Okay, let's start with the question one there. Okay, so question one, what are they saying? Okay, so on question one, they're saying convert 135 degrees into radians. So here we're just going to use the relationship. We know that pi radians is actually the same as 180 degrees. Okay, so now we have 135 degrees. How many radians are we going to have? So we cross multiply. So it means I have 180 degrees x is equals to 135 pi. Okay, these are degrees here. So I can divide with the 180 degrees, even there are 180 degrees. So it means my x, which is my angle in radians, will just be, okay, here we can just simplify this. Okay, so we can look for a number that we can divide into this number and this number so that we have ratios in their lowest terms. Okay, so let's try to divide by 45. So how many 45s do we have in 135? So 135 divided by 45, I'll get 3 pi. And then 180 divided by 45, I get 4. Okay, so it means 135 degrees is the same as 3 pi over 4 radians. And we're done question one. We move to question two. Convert 5 pi over 3 radians to degrees. So here we're doing the opposite, right? So we still use the same relationship. So we know that pi radians is the same as 180 degrees. So now we have pi over 3 radians. How many degrees are we going to have? So we cross multiply. We're going to have x pi is equals to 5 pi over 3 multiplied by 180. Okay, so we can say 3 there, it's 1. 3 into 18 is 6. 3 into 0 is 0. Okay, and then from there, what do? We multiply. So 5 pi multiplied by 60. 5 pi multiplied by 60, I get 300 pi. Okay, and then here I have x pi, remember? So I'm going to divide both sides by pi. So I end up with x is equals to 300 what? Degrees. So 5 pi over 3 radians is the same as this. So here the correct answer was what? D. On the previous question, I forgot to mention the correct answer here was this one, A. Okay, and then now question 3, we're saying, without using a calculator, find the exact value of sine. And then in the brackets, they've put cos inverse 5 over 13 like that. Okay, so what we have to know here is that whatever is in the brackets here, this is just an angle, but it is being represented as a function of cosine. Okay, so we're going to say let whatever is in the bracket here be equals to theta. So I'm going to say theta is equals to whatever I have there. Okay, and then from here, I'm going to multiply the left and the right side by cos. Okay, so if I multiply this one by cos, I get cos theta is equals to, if I multiply this by cos, it means it's going to cancel with the inverse here. So I just remain with the 5 over what? 13. So now, remember your SOHCAHTOA. SOHCAHTOA. Okay, so this means that sine theta is equals to opposite over hypotenuse. Cos theta is equals to adjacent over hypotenuse. And then tan theta is equals to opposite over what? Adjacent. So if I write my right angle triangle like that, and then I say this is my theta, this is my 90 degrees, this here will be my hypotenuse. And then where the angle is facing is my opposite. Down here, the side that has both angles is the adjacent. Okay, so it means this cos theta, which is equals to 5 over 13. Okay, the 5 is the adjacent. and the 13 is what? The hypotenuse. So we can actually put these values on a right angled triangle. So this is my theta, my adjacent is 13, and then my hypotenuse is 13, and then our adjacent here down, okay, I don't have enough space there, is 5. So we have something like this. Let me draw it here. So we have your theta, right angled, 13, and then here we have 5, and then this one is the opposite. So we don't have the opposite there. So we need to find it using Pythagoras theorem. So we know that Pythagoras theorem states that the hypotenuse squared, okay, should be the sum of the adjacent squared plus the opposite squared. But the adjacent, we know its value, it's just 5 squared. Okay, opposite we don't know. So it means opposite squared will be equals to 13 squared minus 5 squared. So you take the 5 squared to the other side. So 13 squared, that gives me a 169 minus 5 squared, that is 5. So it means O squared will just be 144. So now you take the, okay, this is O. You take the square root of both sides. So it means your O will just be what? 12. Why am I writing theta? Okay, so opposite is actually equals to 12. So this guy here is 12. Okay, so now remember we said this is just theta there. Okay, so to find now the value of this, okay, we're just going to replace whatever is there with theta, and then we use this triangle. Okay, so from the triangle, if I want to find sine theta, okay, remember this theta is the same as whatever we have in the brackets, to be equals to, we said opposite over hypotenuse. So the opposite now is 12, and the hypotenuse is what? 13. So this is the correct answer here, 12 over 13. So you come here, you look for 12 over 13, which is B. Okay, let's look at a similar question. So this one, the same. So without a calculator, here they have tan, and then inside the brackets, they have sine inverse of 2 over 3. So we're going to use the same technique. We're going to say theta is equals to this, 2 over 3. So multiply both sides by sine. Here I get sine theta is equals to, if I multiply this by sine, it means the inverse cancels. So I just remain with 2 over 3. And then now I put this on a right angled triangle. Okay, so this is my theta, right angled. So opposite, hypotenuse, adjacent. So now from my sine, okay, sine it's so. So meaning opposite over adjacent. So the opposite is 2. The hypotenuse I mean here is what? 3. Okay. And then for the tan, since this one is the tan, so we're going to take whatever is inside here as the tan. So that would be tan theta. Okay, remember the theta is this guy, is equals to, this is TOA from SOHCAHTOA. So this is opposite over adjacent. So it means we have to find the value of this using Pythagoras theorem. So again, it will just be 3 squared is equals to 2 squared plus adjacent squared. So adjacent squared will be equals to 3 squared is 9 minus 4 squared, 2 squared is 4, I mean. And then here we have adjacent squared is equals to 5. So we take the square root. So it means my A here, the adjacent, will just be the root of 5. Okay, so my adjacent is the root of 5. And then my opposite is 2. So I'm going to write 2 over root of 5. But now notice that on the answers here, we don't have such an option, right? So there we have to rationalize the denominator. So I'll multiply the upper part, okay, and the lower part by the root of 5. So you did this in your first semester, rationalizing. Okay, so I get 2 root 5 over root 5 multiplied by root 5. This is just 5. And you can see now that we have such an answer here, which is that guy there. Okay, so our correct answer here, we're going to pick C. Okay, question 5. Find the amplitude of this. Okay, so here there's no thinking. The amplitude is just this guy here in front. So you pick 3. Okay, and then question 6. A patient's body temperature in degrees Celsius varies over a 24-hour period according to the equation. So they've given us this equation here, okay, where the T is the number of hours after midnight. So now the question comes, find the body temperature at T is equals to 6 hours. Okay, so we have the equation there. So just replace. So this would be 37.0.5 cos. So here I have pi multiplied by t, but t now is what? 6 over 12. So this will be the same as 37 plus 0.5 cos. This here, I'll say 6 into 12, that is 2. So that is pi over 2. But what is cos pi over 2? Okay, so this is the same as cos 90. Pi over 2 is 90. So cos pi over 2 is 0. So 0.5 multiplied by 0, that will just be 0. So the answer here will just be 37 degrees Celsius. So that's the answer there for our what? Our T. So we're going to come back here and pick B as the best answer. Okay, what about question 7? So there now we are solving our trigonometric equations. So again, they're saying, so for x, where x is between 0 and 2 pi. Okay, so this is a full circle from 0 to 2 pi. So we have 2 sine x plus 1 is equals to 0. So let's make sine x subject to the formula. So this will be 2 sine x is equals to minus 1. And then I divide both sides by 2. So it will be sine x is equals to minus 1 over 2. Okay, so it means x will just be equals to the sine inverse of 1 over 2. So you ignore the negative when you put it in this form, okay? But we are going to use it to find the appropriate answers. So now notice that here, the angles are in radians, okay? So it means what you'll be finding here should be in radians. So you put your calculator in radian mode, and then you do, okay? So mode, okay. So you put your calculator in radian mode, and then you say sine inverse of 0.5 or of 1 over 2. Okay, so what are you going to get there? So let me do that. Okay, so radians and then sine inverse of 0.5. Okay, now here I'm getting decimals. Okay, but the answer that you're going to get should be a 30 degrees. Okay, so 30 degrees, we can turn it into radians. Okay, so by that formula that we are using on question 1 and 2, you can say now 30 degrees, okay, x cross multiply to just be x is equals to 30 pi over 180. So this will be x is equals to, cancel 0, 3 there, 1. So I have pi over 6. Okay, so 30 degrees is the same as pi over 6. So in radians, this is going to give me pi over 6. Okay, so pi over 6 is an angle in the first quadrant. Okay, but here notice that this guy, the sign here is negative. So if you draw your 4 quadrants, or students take calc. So the sign is negative in the third and the fourth. And how do you find the angle in the third and the fourth? Okay, so if it's here and you're using radians, okay, you're going to say pi plus the angle that you find there. Okay, plus the angle that you find. Then if it's here, it will be 2 pi minus the angle that you find there. So these will be our answers there, but we have to find the exact values here by using this one, because this one is the same as 30, right? So it will be here to be in the first quadrant, but this sign here is negative, so we have to get angles from here where I see negative. Okay, so let's find. So the first value, okay, will be here. We're going to say our angle, which is x, will just be pi plus the angle that we found, which was pi over 6. So we can say this is 6 pi over 6 plus pi over 6. So I'm just putting 6 here so that I can add easily. So this will just be 6, and then 6 pi plus pi, that will be 7 pi. Okay, so this will be my first answer. My other one to be 2 pi, because it's in the fourth quadrant now, minus pi over 6. Okay, so I can multiply the top by 6, that will be 12 pi over 6 minus pi over 6 is equals to, so common denominator is 6, and then 12 pi minus pi, that would be 11 pi. So this will be my second answer. So you check for your options now where you have this and this as a combination. So we see that it is on what? It's on A. So that's what we are going to pick there as our best answer. Okay. And then question 8, they're saying, So for all x, okay, now here x is from 0 to 180, and our angles are in degrees. Okay, so this is a quadratic trigonometric functions. Okay, so we are going to, how are we going to solve it here? Okay, we notice that we have sine and cos. So we're going to change the sine into a cos. Okay, so we know that cos squared x plus sine squared x, this should give me a 1, meaning that sine squared x is just equals to 1 minus cos squared x. Okay, so we're going to replace this guy with the cos. So it will be 8, where there's sine squared x, I put 1 minus cos squared x minus 3 cos x minus 5 is equals to 0. So this one, okay, I have 8 minus 8 cos squared x minus 3 cos x minus 5 is equals to 0. So I would like to make the coefficient of cos squared x to be a positive number. So what am I going to do? I'm going to take all these guys to the other side so that this one here becomes positive. Or in simple terms, I'm going to divide everything by -1. So what do I get? Okay, I get 8 cos squared x. This one also becomes plus 3 cos squared x. This one also becomes plus 5. This one here becomes minus 8. It's equals to 0. So it means 8 cos squared x plus 3 cos x. And then here it will be just be minus 3 is equals to 0. Okay, so that is the quadratic equation that we are now going to solve. So we try to find the factor, the product, and the sum. So product, factor, and sum. So the product is 8 multiplied by minus 3. That will be minus 24. Okay, and then the sum is 3. So now we're trying to look for two numbers. Okay, we're trying to look for two numbers such that when we multiply them, okay, we get, okay, when we multiply them, we get minus 24. And then when we add them, we get plus 3. So are there any two numbers that we can use in order to achieve that? Okay, that we multiply them, we get that, and then when we subtract them, we get that. Okay, so I think there are no numbers there that we can use. Okay, I think there are no numbers that we can use, unless otherwise. So what we are going to do is that we are going to use the formula method, okay? Because we can't find the factors. So we can use the formula method. So what we're going to do is we're going to say, because we're solving for x, right? Okay, so we're going to say let y be equals to cos x. So it means here the equation will just be 8y squared plus 3y minus 3 is equals to 0. Okay, and then now let's find, okay, let's find the y using the quadratic formula. So it will be y is equals to plus or minus, okay, plus or minus b. It should be like minus b plus or minus the square root of, okay, b squared minus 4ac divided by 2a. Okay, so our a is the coefficient here, our b is the coefficient of x, this is our c. So y will be equals to minus b, so that is minus 3, plus or minus the square root of b squared to be 9. Okay, and then here I have minus 4, a is 8, c is minus 3. So this is like, okay, this is like a 12 multiplied by 12, or you can just say 4 multiplied by 3 multiplied by 8. So that gives me a positive 96. So add plus 96 there. Okay, that's what I get. And then from there, I'm going to divide by 2a. So a is 8 multiplied by 2, that will be 16. Okay, so it means my y will be equals to minus 3 plus or minus the root of 9 plus 96, that's 105 over 16. So we can find two values of y here. Okay, so we're just going to use our calculators. Y will be equals to, the first one will be minus 3 plus root of 105 over 16, or the other one will be minus 3 minus root of 105 over 16. Okay? And then we punch this onto our calculators to see what we get. Okay, so the first one, this one with a plus, I'm getting 0.4529. So please confirm with your own calculators. The other one, I'm getting a minus minus 0.8279. So these here are my values of y. Okay, but my purpose here is to find the values of what? The values of x. Okay, so we know what y is. Y is equals to cos x. So I'm going to say for this first one, it will be cos x is equals to 0.4529. So x will just be equals to, you get the inverse. Okay, so cos inverse of 0.4529. Okay, let's punch this into the calculator. Cos inverse of 0.4529. Okay, so what does that give me? Cos inverse of 0.4529. Okay, so this gives me a 63.07010227. So it means the first value for x will just be 63.1 degrees. Okay, so I used this one. What about if I use this one here? So that one will be, will be what? Will be cos x will be equals to minus 0.8279. Okay, so this will be x cos inverse. Okay, I ignore the negative first of all. Okay, so let me do that. Cos inverse of 0.8279. So that one gives me what? Okay, gives me 34 point something. Okay, so 34.116383. Okay, but this one would be an angle in the first quadrant. Okay, be an angle in the first quadrant. But this guy here is negative. So I have to get an angle in a quadrant where the cos is negative. So remember, when you have all students take coke. So cos is only positive here and here. And then here and there it's negative. So we need to find the angle here. Okay? There. Because this range here for the x is coming from 0 to 180. Okay? So if it was going all the way up to 270, we would have also found the angle here. But since it's 0 to 180, we just need the angle here and the angle here. So this first equation here gave us a 63.1 degrees. The 63 is just here. Okay, so there was no problem there, just we got it directly. But this other one here has given us a 34. But this 34 here, okay, is for a positive value. But here we are the what? A negative value. So what do? Okay, we use it to find the angle there. So the angle in this second quadrant is found by 180 minus the angle that you are going to find here. So that will be the angle in the second quadrant. So let's find it. So I'm going to say my angle in the second quadrant. So x will be equals to 180 minus 34.116382.3. Okay, so that is 180 minus 34.116382.3. Okay, so 180 minus 34.116382.3. Okay, so that was is giving me 145.8888. When I round it off to one decimal place, that would be 9 degrees. So you see that our two answers will be this one and this one here. So you check on the options where you have those. So it will be D there. Okay, so be careful with the intervals of the allowed x that you've been given there. Okay, so here we are finding from 0 to 180. No wonder we found an angle there and an angle there. Okay, if it was going all the way to 360, we would have even found the angle here. So we would have 3 answers there. Okay, so question 9, still the same. So here now we have 4 cos 2 pi minus 3 is equals to 0. So this will be 4 cos 2 pi is equals to 3. And then we divide both sides by 4. So it will be cos 2 pi is equals to 3 over 4. Okay. And then okay, we can find the inverse now. So 2 pi will be equals to cos inverse of 3 over 4. So what is cos inverse of 3 over 4? Okay, cos inverse of 3 over 4, it's 41 point, 41 point what? Okay, okay, so 41.41 degrees. Okay, so now notice the angle that we have here. So here they have said the theta is from 0 to 360, right? And then here we have 2 theta. So this simply means we have 2 cycles, okay? One is from 0 to 180, a complete cycle of the cos. And then the other one is from 180 to what? To 360. Because here we have 2 pi. Okay, remember when you're finding the periods there when we're graphing these trigonometric functions. So it means within 0 to 180, there are 2 answers there. Okay, that's what it means to have a full cycle. And then from 180 to 360 again, we have 2 answers. So here, we're going to have 4 answers for the what? For the 2 pi. Okay, so the first one is this one that we found here. So how do we get the second one? Okay, so this is just positive, positive. So if I draw my quadrants, all students take coke, right? So the cosine is positive here and here. Okay, it's positive there and there. So it means this one is the angle in the first quadrant because this is 0, 90, 180, 270. Then I come back 360. So the angle, this one, 41, it's there. So I need to find another angle, which is here. So how do you find the angles in the fourth quadrant? You do 360 minus the angle that you find in the first. Okay, so my other 2 theta will just be equals to 360 minus this angle in the first quadrant. So let's do that. So we have 360 minus 41.41. Okay, so that gives me my 2 theta to be equals to 318.59. Okay, so that is what I have. That's what I have there. Okay, and then from there, what are we going to do? Okay, since we have 2 pi here, okay, we're going to add a 360 here and then also add a 360 there to get the other 2 thetas. Okay, so what we are going to do is this. Okay, so remember the first one was that 41, and then we used this scenario to find the other one. So my 2 theta, the first one was 41.41 degrees. The other one was 318.59 degrees. Okay, so the other 2 thetas now, remember we said the answers should be 4. I'm going to add 360 to this, okay, and 360 to that. So it will be the other one to be 2 theta, okay, that will be 41.41 plus 360. So that will be okay, that will be 401.41 degrees. Then the other one will be 2 theta is equals to this one plus 360. So 318.59 plus 360. So that gives me 678.59. Okay, so now to find theta, we're going to divide all these numbers by 2 because this is 2 theta, 2 theta, 2 theta, 2 theta. Okay, so we start with the first one, 41.41 divided by 2. Okay, I get 20.7 degrees. Okay, what about this one here? Okay, so 318.59 divided by 2, I get 159.3 degrees. Okay, and then I divide this one, 401.41 divided by 2. I get 200.7 degrees. And then the last one now will just be this guy divided by 2. Okay, so we have 678.59 divided by 2. So that gives me 339.3 degrees. So now these will be our values for theta. Okay, so we added 360 here because we have 2 pi. Okay, so if you had, if for example you had 3 pi, it means you have 6 solutions. So you add 360, you get this, you add 360, you get this, and then again to these numbers, you add another 360 to get the third the to get the other two thetas. Okay, so you get another one here, another one. If you had 4 pi, it means to whatever you get here, you also add another 360, just like that. Okay. All right, so these are our answers, and we can see that we find them where? C. So this is C here, the correct answer. All right, let's look at question 10. So here they're saying, without the calculator, verify, is this identity true? So now look at what we have on the left-hand side. On the left-hand side, we have 1 plus sine x divided by cos x. So we can actually distribute this cos x to the 1 and sine x. So I can say 1 over cos x plus sine x over cos x. Okay, but is that true? Okay, is that true? Is that true that this here will be equals to sec x minus tan x? No, because this here in itself will just be sec x. And then plus, this we know is tan x. So what we have is that on the left-hand side, we have sec x plus tan x. But on the right, okay, we have sec x minus tan x. So we see that these two are not equal, okay? They are not equal. So we're going to say this identity, okay, is actually false, okay? It's actually false. Okay, so now here we have to analyze because we have to find the perfect answer. Okay, so A, they say the identity holds true. This is definitely false. It can't be the answer because we see they are not equal, right? Okay. Okay, so we have proved that the identity is not the same. Now we are trying to look for a perfect answer. Okay, so the first one here, option A, they were saying the identity holds true. We found that this is false. Okay, and then they're saying B, identity is false for all x. Okay, we don't know that unless we try some specific values. And then here they're saying the identity is only true if x is equals to 0. So if x is equals to 0, then I have sec 0 minus tan 0, okay, is equals to sec 0 plus tan 0. Okay, so this is 0. So what is sec 0? Okay, so that is 1 over cos. So that would be cos 0 over 1. So 1 over cos 0 minus tan 0. Okay, so cos 0, this is not theta. Why am I writing theta? So cos 0 is actually 1. So this will be 1 over 1 minus 0 is equals to, this will still be 1 over 1, and then plus tan 0 is 0. So this identity here is actually only true when x is equals to 0. Okay, it's only true when x is equals to what? To 0. Okay, what about if we tried 90? So that would be 1 over cos 90, but cos 90 is 0. 1 over 0, it doesn't even make sense. It's invalid. Okay, so the inequality, this one, is only true when x is equals to what? To 0. Okay, it's only true when x is equals to 0. Alright, so you pick C as the best answer there. Okay. Alright, and then question 11, they're saying a spherical tumor is growing as blood accumulates within it at a constant rate of 0.2 cubic centimeters per day. So this cubic centimeters per day, this simply means that's my dV dt, because this is the volume, this is the time, so this is dV dt. So dV dt is 0.2. okay, and then here they're saying the surface area and the volume of a tumor relate to its radius by this formula and this formula, okay, respectively. As the attending physician, determine how fast the surface area of the tumor is increasing when its radius reaches 0.5 centimeters. So how fast the surface area of a tumor is increasing, that's dA dt, because you are trying to find how fast the area is increasing within a specific time. So you're finding dA dt. So here our aim is to find dA dt. Okay, but how do we find dA dt? So let's derive it. So if I have dA dt that I want to find, okay, it's the same as, okay, because from this A is equals to this, I'm going to get my dA dr. From here, I'm going to get my dV dr. Okay, so dA dt will be dA over dr, but I don't want this dr, so it should cancel with something. So I'm going to get the reciprocal of this, so I'm going to flip it. So it's going to be dr dV, and then multiplied by, here I have my dV dt. So you can see how they are cancelling, right? This dr cancels the dr, the dV cancels with the dV, and then you remain with your dA dt. Okay, so just have to find this, find this, find this, and then multiply them to get the answer. So we start with the dA dr. So dA dr, okay, we're just differentiating this guy with respect to r. So that will be 8 pi r, okay, but now we are evaluating it at 0.5, so that will be 8 pi and then 0.5, so that will be like what, 4 pi. Okay, and then we find first of all our dV dr, I mean, and then we flip it, we find its reciprocal, so that will be dV dr. Here we're differentiating this with respect to r, so the 3 comes and multiplies the constant term in front, so that will be 3 multiplied by 4 over 3, and then pi r, it reduces this power by 1, so that will be 2. Okay, so here I'll just get 4 pi and then 0.5 squared. So what does that give? So 0.5 squared gives 0.25, okay, and then 0.25 multiplied by 4, that will just be 1. So this gives me a pi, actually, like that. Okay, so this is my dV dr. Okay, so where I have the pi here, I can write it as pi over 1. Okay, I can write it as pi over 1. So now my interest is dr dV, so I take the r dr on top, the dV down. Even here I'll do the same thing. So what I have is my dr dV will be equals to 1 over pi. Okay, so dr dV will just be equals to 1 over pi, and then this dV dt, we already have it is 0.2, so you can just put in that formula and then multiply. Okay, we can just put in this formula and then multiply. So we're multiplying this with this. Okay, now I'm erasing things. We're multiplying this with this and that, so this will be equals to, okay, dA dr is 4 pi multiplied by dr dV is 1 over pi multiplied by 0.2, so that will just give me 0.8. okay, and this will be area with respect to time, so that will be squared centimeters per day. Okay, so our answer here will just be B. Okay, question 12, they're saying a curve C is defined parametrically by these equations here. Okay, where theta is between minus pi over 2 and pi over 2. Okay, so it's between minus 90 and 90, and then y is between minus k and k. Find its Cartesian equation, okay, where x will be equals to a function of y, like that. Okay, so what do you think we can do here? Okay, so the equation that we have is x is equals to cos squared theta, and then we have y is equals to root of 3 sine theta. Okay, so let's make sine the subject here. So it will be sine squared will be equals to, so it means here I'll just divide everything by root of 3, right? So that will be y over root of 3. Okay, and then from here I'm going to square both sides here. So it will be sine squared theta, and then I also square this side to just be y squared over root of 3 squared to just be 3. Okay, so why am I doing this? You get to know. So now look at this x. X is equals to cot squared theta. But what is cot? Cot is the same as cos squared theta over tan, over sine squared theta. Okay, so sine squared theta, we already have it here. Okay, but from the identity we know cos squared theta is the same as 1 minus sine squared theta. So here where there's cos squared theta, I'm going to put 1 minus sine squared theta over sine squared theta. Okay, so on top it will be 1 minus over 3 divided by, okay, y squared over 3. Okay, so from there what are we going to do? We're just going to simplify this. Okay, we're going to simplify this by multiplying the denominator and the numerator by 3. So if I multiply here by 3 and there by 3, what do I have? So on top there to be 3 multiplied by 1, I get 3 minus y squared over 3 multiplied by 3, I just get y squared divided by y squared over 3 multiplied by 3, I get y squared. Okay, so it means there this will be my answer in terms of x, because remember this was x is equals to this, x is equals to that. So x is simply equals to 3 minus y squared over y squared. So you look for where you have such an answer here, which is C. So C there was the perfect answer. Okay, let's look at 13. We're still dealing with parametric curves. So here they're saying x is equals to 3 cos 2t, y is equals to 5 sine t. T is between minus pi over 2 and pi over 2 and has the gradient function, okay, minus alpha cosec t. State the value of alpha. So here we're just going to use these two equations here to find dy dx. Okay, so from this one I can find dx dt. From this one I can find dy dt. And then I'm going to divide those in a special way to come out with the dy dx. So x is equals to 3 cos 2t. So if I find my dx dt, if I differentiate this with respect to t, I'm going to get 3. Then what is the derivative of cos? It's a minus sign, and then you maintain the angle. Okay, so here I'm using the chain rule. It means I'll also multiply by the derivative of this function here, which is just 2. So it means this one is minus 6 sine 2t. But what is sine 2t? Okay, so remember from the double angle formula, if I have sine A plus B, this will just be sine A cos B plus sine B cos A. So now imagine you have sine t plus t. That will just be what? Sine t cos t plus, okay, plus here it will be still sine t cos t. So these are the same thing, so it will just be 2 sine t cos t. Okay, so where there's this guy here, I'm going to put this. So this will be minus 6, and then where there's this, I'm putting 2 sine t cos t. Okay, so that will be my dx dt. What about my dy dt? So y is equals to 5 sine t. So it means dy dt will just be equals to 5 cos t. This one's very easy. So now to find my dy dx, okay, I'm just going to divide these two here in a special way. So look at this. Okay, so I'm going to say dy dx is equals to dx over dt, and then I multiply this by dt over dx. So remember, this is my dx dt. So my dt dx, it will just be the reciprocal of this. So my dt dx will just be minus 1 over 6. That 6 now I can even multiply it with these two. So that will be 12 sine t cos t. Okay, so I can put now in that formula. So my dy dt, it's 5 cos t multiplied by dt dx is this. So that will be minus 1 over 12 sine t cos t. Okay, so from there we see that there are things that can cancel. So the cos t and the cos t, they cancel. So it will be minus 5 over 12 sine t. So this is what we have as our dy dx. Okay, so we'll factorize the, not necessarily factorize, but we're just going to say 5 over 12 and then multiplied by sine t. Oh, multiplied by 1 over sine t. So multiplied by 1 over sine t. Okay, so this will be minus 5 over 12 multiplied by, but the 1 over sine is the cosec t. Okay, so you can see here that our dy dx is this guy, and then here we are given that it's this guy. So it means this alpha, okay, the minus alpha is just equals to this. Okay, so what will be the value of the alpha now? Okay, so I'm going to get minus alpha should be equals to minus 5 over 12. So divide both sides by a negative, you get alpha is actually equals to 5 over what? 12. So the answer there should be B. Okay, don't confuse it with the minus. Okay, so the answer there is B, so you pick B here. Okay, so what about this one? Here they're saying a curve C is parametrically defined, this and that. Okay, and then the y is between minus k and k. So they say state the value of k. So here y we've been given as root of 3 cos theta, right? So we're going to evaluate this y at 2 points, one at pi, the other one at 2 pi. So the first one will be at pi, so it will be root of 3 cos pi. The other one to be y is equals to root of 3, okay, cos 2 pi. So what is cos pi? Okay, so that's the same as cos 180. So that will be minus 1. So minus 1 multiplied by the root of 3, it's minus root of 3 is equals to, here it will be root of 3 multiplied by cos 2 pi. So cos 2 pi, it's 1. Okay, so this will just be root of 3. So y is between these two numbers. So you can say y is between root of 3 and minus root of 3. But again, we are given this. So what is the value of k? The value of k is just root of 3. Okay, so you pick A. Okay, next one. Find an equation of the tangent to the curve. This is the curve at the point 1, 0 in the form of a straight line there. Okay, so the curve is x squared plus 2xy plus y to the power 3 is equals to 0. So we're trying to find the tangent, okay, to this curve at a certain point. So what are we going to do? We're just going to use implicit differentiation to differentiate this. So I'm going to multiply throughout by dy dx. Okay, so dy dx of this, I get 2x plus, here I have two variables, so I'll use product rule. So my u will be 2x, my v will be y. So we said you differentiate first the u. So if I differentiate 2x, I get 2. And then I multiply by the v, which is just y. And then plus, now I keep the u, I differentiate the v. So the v is a function of y. So when you're using implicit differentiation, then you have to put your dy dx there, wherever there's y, right? So the derivative of this y is actually 1. And then since it was y, I put dy dx. Plus, here, this is y. So I differentiate it in the normal way. So it will be 3y squared. But because it was y, I put dy dx. Okay, is equals to, what's the derivative of this? It's just 0, because it's a constant. Okay, so this is what we have, and we want to find the dy dx. Remember, the dy dx is the gradient. Okay, so at the point 1, 0. So wherever there's 1, okay, wherever there's x, I mean, we put 1. Wherever there's y, we put 0. So this will be 2 multiplied by 1 plus 2, 0 plus 2, 1 multiplied by 1 dx dy dy dx plus, where there is y, we put 0. So this whole thing becomes 0 is equals to 0. Okay, so what do we have now? We have 2 plus 2 dy dx equals to 0. Okay, so it means my dy dx will just be equals to minus 2 over 2, which will just be minus 1. So the gradient is actually minus 1. Okay, the gradient is minus 1. And the point is 1, 0. And the gradient is minus 1. So you can use the equation of a straight line to find this now. So 1, okay, minus y1 is equals to mx minus x1. So my y1 is 0 is equals to the gradient minus 1 x minus 1. So this will just be y is equals to minus x plus 1. Take everything to the left, so it will be y, okay, plus x minus 1 is equals to 0. And then we can write it in the form that they wanted, starting with the x. So it will be x plus y minus 1 is equals to 0. So this is our answer here. And we can see that that answer is on C. So we pick C. Okay, so now we are just remaining with 5 questions. So let's look at the next one. So here we've been given y is equals to 3 tan inverse of 2 minus x. And then we are asked to differentiate it. So we are finding dy dx. Okay, so now notice this. If my function is y is equals to tan inverse of x, then my derivative dy dx will just be 1, which is the derivative of whatever is inside there, divided by 1 plus this x, and then you square it. Okay, so I have 1 over 1 plus x squared. So here I'm going to use the same thing. So where there was x here, okay, in this form, they have just put now 2 minus x. So I'm going to differentiate this part with respect to x. That will be minus 1 over 1 plus this whole thing squared. So this will just be minus 1 over, okay, oh, I forgot this 3 here. So there's a 3 in front like that, and then the derivative of this part is what I've written there. So 3 like that. So down here now it will be this guy multiplied by itself. So it will be 2 multiplied by 2, that will be 4. Okay, 2 multiplied by minus x multiplied by 2, that will give me minus 4x. Then minus x multiplied by minus x, that will be plus x squared. So it means my answer will just be minus 3 over, okay, here it will be x squared minus 4x plus 5. So this will be my dy dx. Okay, but you notice here we do not have any. Okay, so I'm pretty much sure they forgot this negative here. Okay, they forgot the negative there, but the answer that is closer, it's actually this one here. Okay, the one on D. So there should be a negative here because here we have 2 minus x. So when you differentiate there, you get a minus 1. Okay. And then 17, we have this one. So now here we have to know the derivative of a sec x. So the derivative of a sec x is sec x tan x. Okay, but here we're going to use the chain rule. Okay, we're going to use the chain rule. Oh, okay, we're going to use the chain rule. So the chain rule states that. Okay, so here, even here, we're using the chain rule. So I was wondering where this one here, the negative one, is still there. So you differentiate first of all this one, like I said, and then you're also going to differentiate this inside function here, which will give you a negative 1 outside. So this negative 1, okay, is going to multiply with that negative 1 and it's going to form a positive here. Okay, so I've corrected there. Okay, so the answer is still D there. Okay, so it's going to be positive because of this negative 1. We're using the chain rule there. Okay, so even here we're going to use the chain rule. So it will be dy dx is equals to, this is sec of an angle. So the derivative is just the function itself, and then I write tan of the same angle. But now I multiply with the derivative of the inside here because it's a chain rule. So the derivative there is minus 1. So it means my answer there will just be minus tan 1 minus x, and then sec 1 minus x. Okay, so that is the answer. We find it where? On B. Okay, find it on B. Alright, question 18. Here we are using the quotient rule. Okay, so the quotient rule says if I have u over v, then the derivative will just be u prime v minus v prime u divided by u squared. So y is equals to ln 2x over 3x. Let this guy be my u, this one be my v. So I'll first differentiate the u. So the u is ln 2. So how do you differentiate a ln? Okay, you differentiate whatever is there with respect to x. So the derivative of 2x is 2. And then you divide with the function itself. That's the derivative. Then I'm multiplying this by the function v, which is 3x. Then I say minus. I now differentiate the v, which is 3x. So I'll get 3. Okay. And then I multiply with the u, which is ln 2x. And then I say divide all this by u squared, which is 3 squared. Right? Okay. So that is what we have there. That's what we have. So it means on top there, here, okay, it's going to be 2 and 2, they can cancel, so I remain with 1 over x. This x and this x can cancel, so I remain with 3 minus this 3 will multiply with this, I get 3 and then 2x divided by, okay, here down I'm going to have 9x squared. Okay, but there's 3 here, there's 3 here, and even there 3 is common. So what can we do? We divide throughout by 3. So I divide that by 3, I get 1 minus then 2x over this one. I divide by 3, I'll get 3x squared. So the answer is this one here. Okay, so you check for the answer that has this guy. So it's which one now? Okay, it's this one here. Okay, so the answer is C. The correct answer there is C. Okay, so we can now solve question 19. Okay, which is very simple. So here we are given 2, 1 minus x plus 3xy is equals to 0. Okay, so they're saying find the exact value of the dy dx at the point with the coordinates 1, 1. So here we are using implicit differentiation. Okay, so we're going to apply dy dx throughout. So the dy dx, this is an exponential function. How do you differentiate that? You differentiate the power with respect to x. I'm going to get minus 1. Then you multiply with the ln of the base that you had here, which is 2. Then multiplied by the function itself. Okay, so that's the derivative here. And then here I'm going to use implicit because I can see x and y. So I'm taking this as my u, the 3x, and then my v as my y. Okay, so it will be plus the derivative of u to be 3 multiplied by y plus the derivative of v, which is just 1. Okay, but since it's y, I'll add the dy dx. Okay, and then multiplied by the function of u. So it will be 3x dy dx. The derivative of 0 there is just 0. Okay, and then we are finding this at 1, 1. So we can put these values there. So it will be minus 1 here, ln 2, and then multiplied by 2, 1 minus 1, plus 3, 1, plus 3, 1, dy dx is equals to 0. Okay, so here we're just going to get what? Minus ln 2. This is 2 to the power 0 because this is 1 minus 1. So it will just be 1. So we just get minus ln 2 and then plus here to be 3 plus 3 dy dx. Okay, this is equals to 0. So I can take these guys to the other side so that I'll have 3 dy dx is equals to ln 2 minus 3. Okay, and then I divide both sides by 3. So it means my dy dx will just be ln 2 minus 3 over 3. So you check the one that has this answer here. We see that it's what? B. Okay, that's all for that. And then the last question. Okay, so this one is very easy. Okay, so this one is very easy. What are they saying? Okay, so they are saying the curve C with parametric equations, this one and this one, okay, has a minimum turning point at P. So if the dy dx is equals to root 3 over 5 sine theta, find the coordinates of P. So P is actually the turning point. So what do we know about the derivative at the turning point? We know that at the derivative, at the turning point, I mean, the derivative is always equals to what? To 0. So that's what we are going to use. So we're going to equate this derivative, root of 3 over 5 sine theta. We're going to equate it to 0. So this will just be sine theta will be equals to 0. Cool. Because I'll divide this here, and then 0 divided by this just 0. So theta will be equals to sine inverse of 0. So what will be that? Okay, so that will be sine inverse of 0. That will be 0. Okay, sine inverse of 0, that will be 0. Okay, so this is 0. The sine inverse of 0 is 0, right? But now look at the range for the accepted values for theta. They said theta should be between pi over 2 and 3 pi over 2. So this is 0. This is pi over 2. This is 3 pi. This is pi. And then this is 3 pi over 2. And then this one is 2 pi. So I've found my theta to be 0, which is an angle in the first quadrant. Okay, but here they said my angle should be between this and this. So it should be between here or here. Okay, so I find my corresponding angle here or there. Okay, so to find the corresponding angle here, because this sign here is positive, we're going to use the second quadrant. So in the second quadrant, the angle there is pi minus whatever you find the angle is here. Okay, so the angle that we found here is 0. So it means the angle there, theta, will just be pi minus 0. So pi will be equals to what? Theta will be equals to pi. So the pi, the theta that we are going to be using is pi here. Okay, so once we find our pi, we can use those equations on top there to find the x and the y coordinates. So for the x, we are going to say 5 tan pi minus 3. So what is 5? What is tan pi? Okay, or tan 1/8. So that is 0. So this part becomes 0 minus 3. So it means my x will just be what? Minus 3. Okay, and then What about the y? So the y will be equals to root of 3 multiplied by 1 over cos theta, because this sec here is just 1 over cos. So it will be root of 3 over, what is cos theta? But the theta now there, let's replace with pi. Okay, so cos pi is 1. So this will just be root of what? 3. So it means my y is root of 3, my x is minus 3. So the point P is actually minus 3 comma root of 3. So that will be our turning point. So you pick which one now? Okay, you pick okay, which one do we pick? Okay. Okay, so cos pi is minus 1. Okay, so I made the mistake here. So this will be minus 1, minus 1. So you pick this one on D there. That will be your final answer. Right, so we are done with the questions from your quiz. We've solved question 1 to 20. All right.